using some technology again. Technology, technology, technology. So let's talk about, we want to find mean and standard deviation, but the first thing we're going to talk about is just the mean. So the mean can be done by this formula, which is super easy. Mu of x, because remember that's the symbol for mean, is equal to the sum. Oh my, that looks terrible, doesn't it? Because we want to get that sigma, the sum of x times p of x. So really what we're doing here, if we're looking at this, we're just multiplying these together and then adding each one up. Where x is the value of the random variable, looking at our chart, and p of x is the probability, looking at our chart. Really, all you're doing, if you wanted to do this by hand, is you're going to multiply these together, add that to these multiplied together, add that to these, add that to these. And then that is going to be your mean, because it's basically saying, okay, the probability a 0 can happen is this. The probability that a 1 can happen goes here. Do you see what's happening there? Okay, but we can use technology to find this. Now, the same kind of thing happens for this as happened before. In StatCrunch, it's going to have this little overlapping double box in the corner. You'll click on that overlapping double box and it'll say open in StatCrunch. And then what happens is it automatically puts that in there. So if we're going to find this mean and the standard deviation, right? We're going to find the mean and standard deviation. We're going to use StatCrunch. So let's hit that little double box. I've already got them put in over here. So there is our variable 1 and 2. So this is right from that table. So here are the steps. We're going to do stat, calculator, and then at the very bottom down here it says custom. So you're going to click on custom. And then it's variable 1, variable 2. I almost made it too big where you couldn't even see that, right? I'm going to scoot this up. And there's your mean and there's your standard deviation. So again, we're going to look at this. We're going to go to, just run it through again, make sure we're good. Stat, calculator, and then at the very, oopsie daisy, at the very bottom it is at custom. So it doesn't really say anything that has to do with what we're actually finding. We're just looking at this custom. Because it is 2 variables, it is 2 columns, whatever the columns are called, then that's what you compute, and then that's going to get you your mean and your standard deviation. So I'm going to swing this back over here because I want to make sure that we know our StatCrunch steps are going to be stat, calc, and then calculator, and then custom. I'm making sure that as I look down at my iPad that it's still showing up there. So my mean and my standard deviation. So our mean is 2.39. Our standard deviation, I don't know, let's do 2 decimal places. Why not? 0.71. Oh my. Got a little crazy there. Do you see that right over here? 0.71 because it's rounding. All right. Okay. Okay. And the probability, just for fun, right? So the probability that my x here, notice capital X here, is going to be less than or equal to 3. That means all of it because I have the choices of 0, 1, 2, or 3. And look at this. Here is that distribution, the graph of that distribution that we saw previously. Here's just a graph of it, and then it lays out what my mean and my standard deviation are. And the probability, all of this together, because 3 is the max, it's going to be 1, which makes sense. The probability that's going to happen is all of it. All right, so that is how we set this up. Anytime you want to find the mean and the standard deviation that we're looking for here, you're going to go into StatCrunch, and it'll be stat, calculator, and then custom, and then that's how you'll get your mean and your standard deviation. All right, so in your homework, it will have this double box anytime you have data, and then you click that, and one of the options is going to be open in StatCrunch. It'll automatically populate in StatCrunch for you. Okay, now let's interpret this. So we can find the mean, but let's interpret what it is that we're actually talking about here. That makes an impact. So, suppose an experiment is repeated n independent times and the value of the random variable is recorded. As the number of repetitions of the experiment increases, I'm going to highlight this, the mean value of the trials will approach the mean of the population. Do you see what just happened here? The mean of the trials will approach the mean of the population. All right. In other words, let x1 be the value of the random variable after the first experiment, x2 the second, and so on. If that's the case, so in the mu notation means population, right? We're familiar. So x bar, oh, see, it doesn't go away. I'm telling you, these symbols make a difference. That's the mean of a sample, right? So I have x1 plus x2 plus x3 plus however many it is that I'm adding together for my n trials, however many I have, divided by the total number. How do you find a mean? Add them all up, divide them by the total. Boom, doesn't change. That's still how you find a mean, right? Okay. The difference, here's another nice, awesome thing to take a look at right here. The difference between the sample mean and the population mean gets closer to 0 as your n increases. So as the number increases in my trial, the bigger the trial, law of large numbers. Have we heard this before? Okay then, right? Previous information into the current lesson. I told you the stuff that we've learned before, it's not going away. We're going to see it again, and here it is. This law of large numbers. The more data that we can get, the more accurate it is. For instance, the basketball player from example 2 is asked to shoot 3 free throws 100 times. Compute the mean number of free throws made. I'm getting tongue-tied. Table 4 shows these results. Compare the theoretical from example 5. So I'm going to make this bigger so you can see. So the first time he shot 3, he made all 3. The second time he shot 3, he made 2 of them. Do you see what's happening here? The third time that he shot 3, he made all 3. Do you see what's going down? This time he shot 3 free throws, he made none of them. So this is 100 experiments. How many times did he actually put the ball in the air towards the hoop? 300, right? Because it's 100 experiments, but 3 shots for each one. All right, so you see where this is going. Okay, I bet that boy was tired. All right, so my mean is going to be if I were to add all of those together. 3 plus 2 plus 3 plus plus 3 divided by 100. Now, if we were in StatCrunch, we would have the double box here. I did not put this in StatCrunch because I'm not trying to mess with that. So just know, if we were to add all these up, you can take that with your handy dandy calculator, right? Chug all those out, chug all those out, chug all those out. I'm just telling you, you're going to get 235. Out of 100 trials gives you a 2.35. I'm going to squeeze this down. What was our mean of basketball trials here? 2.39. Do you see that? Out of 100 experiments, what do we have? 2.35. That's getting close, right? That is definitely getting close. So here's the moral of the story. The more trials, we do, the closer we get to our mean of 2.39. Oh my, it just went crazy there on me. I don't know what happened. I must have hit my iPad weird. All right, law of large numbers. The same thing that's happening right here. The difference between our sample mean and our population mean gets closer and closer to 0 as our sample increases. That's the key to that. All right? Pretty cool, right? Yes. It's nice when you have previous information into the current lesson. We already learned about probability, the rules for that. Boom, we're using it here. We've learned about the law of large numbers, how to find a mean. Boom, we're using it here. It's good stuff, really.